All right, good evening and welcome to Master Talker online class. In today's video, we'll be solving questions on the principles of mathematical induction, right? So the first question here is question number 183, and it said to prove by the principle of mathematical PMI, the principle of mathematical induction, that the summation of R as arrow started from 1 to n is equal to 1 over 2 into n plus 1, okay, comma. Then I say the assumption that the summation of r starting from 1 to k of r is equal to 1 over 2 k into k plus 1, comma, leads to. Okay, now I'll show you what it will lead to, but I just want to show you how to prove that this is equal to this by mathematical induction, right? The first thing you do is you assume that Sn statement is true. So how do you do that? Just repeat this question. Just say that Sn is equal to put 1. You have 1 plus 2 plus 3 plus dot 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 plus, then put your n, because you start from 1 to n. Put your n is equal to 1 over 2 n into n plus 1. Okay, that's the first thing. Now the second thing you do is to prove. You prove that S1 statement is true. S1 statement is true. All right, that is what? That S1 is equal to 1 plus 2 plus 3 plus dot 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 plus. Now put 1. 1 is equal to 1 over 2 into 1 plus 1. Okay, so which is 1 is equal to 1 over 2. Everything here is giving me times 2, which is this cancel this. You see that 1 is equal to 1. So this is proved. All right, so when you get that the left hand side is equal to the right hand side, then you continue. So the next statement is to assume. You assume that SK statement is true. Statement is true. How do you do that? Just say that SK is equal to, anywhere you see n in the same thing, put k. That is 1 plus 2 plus 3 plus dot 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 plus k is equal to what? 1 over 2k into k plus 1. Okay, so the next thing we do is we assume that SK plus 1 statement is true. Statement is true. All right, so how do you do that? That is SK plus 1 is equal to 1 plus 2 plus 3 plus dot 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 plus k plus 1 into 1 over 2 into k plus 1 into k plus 1 is this one plus another one, which will give you k plus 2. So this is the answer they need us to get for this particular question, so that this one now will lead to this. Okay, so if you check the option, you will see that the first option here is very, very correct. So this is what they want us to show, okay, for this particular question. But I'm just trying to prove it. On the norm, I'm not supposed to write this thing. I'm supposed to put that anywhere I see k, I should put k plus 1 after writing the first one. But I'm just trying to show you that I just want to prove it. So now the last thing you now do is to prove that SK implies SK plus 1. All right, I'm just solving it. I've gotten the answer, but I just want to prove it by mathematical induction. So what do we do now? Carry the left hand side of SK plus 1, add it to the both side of SK. So for my SK said 1 plus 2 plus 3 plus dot 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 plus k plus, look at my k. I'm now adding this. I want to add this. I'm adding k plus 1 is equal to my right hand side there is what? 1 over 2. In fact, it will not even enter there. So permit me to write it here so that it will be long. So the last thing we have to do is to prove that SK implies SK plus 1. Okay, if you are writing objectives, these are just simple questions they will be asking you, because you are not to prove there. So you just put SK plus 1, you get this, because it's an objective question. But if it's theory, that's where you will do all these ones I'm doing. All right, so let us continue. So we will now say that we are adding the left hand side of sk to both sides, the left hand side of sk plus 1 to both sides of sk. So from my sk, which is what, 1 plus 2 plus 3 plus dot 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 plus k plus, now let me add the left hand side of k plus 1. I'm adding k plus 1 there, is equal to the right hand side of sk is 1 over 2 k into k plus 1. I will still add the same thing, plus k plus 1. So I said add the left hand side of sk plus 1 to the both side of sk. Okay, so now just keep repeating this thing, but what you are solving is now the right hand side, so which is what, this is k into k plus 1 all over 2, then plus k plus 1 over 1. So the LCM of that and that will give you, the LCM of this and this will give you, the LCM is 2. So 2 divided by this is 1. 1 times this will give you k into k plus 1. Okay, plus this divided by this is 2. 2 times this will give you 2 into k plus 1. So I'm going to have that. What do they have in common? If you look at this, you see that they have something in common. They have 1 over 2 in common. So I bring out 1 over 2. They still have k plus 1 and k plus 1. So they have k plus 1 in common. So the only thing remaining now is what? For this side is remaining k, then plus for this side is remaining 2. So if you look at this now, this is the right hand side. We got exactly the right hand side of this k plus 1. So immediately you have gotten the right hand side of the k plus 1, it is proved. So that is how to prove the mathematical induction for this particular question. So we move to the next question. So, but you are not asked to prove it because that's an objective question. I've told you before. So the next question, question number 2, that is question number 184 here, and he said the truth that 10 raised to power 2n minus 1 then plus 1 is an integer multiple of 11. Integer multiple of 11 is established if the assumption that 10 raised to power 2k minus 1 then plus 1 is equal to what? 11m, where m is an integer. Okay, it will now lead to. Okay, so what they'll be asking you for objective question is what it will lead to. Okay, so solution, let me show you how to get it. It's very, very simple. The first method is to assume again. You assume that what? Sn statement is true. Statement is true. Okay, so an Sn statement means Sn is equal to, just repeat the same thing, 10 raised to power 2n minus 1 then plus 1. Okay, so the next thing to do is what? To prove. You prove that S1 statement is true. Right, so what do you do for here? That is S1 is equal to 10 raised to power 2 into 1 minus 1. Okay, all these things are not necessary for objective, but I'm just showing you normally. So plus 1, so which will give you 2 times 1, 2 minus 1 is 1. So 10 raised to power 1, that is 10 raised to power 1 plus 1, which is what? 11. If you notice that 11 is a multiple of what? Is an integer multiple of 11, because 11 can divide 11. So you see that what? 11 is an integer, is an integer and is equally a multiple of itself, 11. So this is true. So you say that what? S1 statement is true. Statement is true. Okay, so the next thing you do is to assume that SK statement is true. Statement is true. Okay, so what do you do? That is SK is equal to, anywhere you see and put k, that is what? 10 raised to power 2k minus 1 then plus 1. Now you assume that this thing is equal to 11 times any number at all you like. Okay, you want to put it by yourself, so we are assuming it. So if you assume that this thing is true, that means you are assuming that this thing is a multiple of 11. So it's going to be 11 times any number. You understand? Because 11 times any number you have where that m must be an element of what? Integer. Then if you put any integer here, you will still get a multiple of 11. If you put 1, 11 times 1 is 11. Are you getting it? You are getting that 11 is a multiple of that. So that is that. So the next thing we look at is so the next thing you are looking at, which is the last thing, is that what? That SK, you prove. In this one, we don't assume SK, but prove it direct. We prove that SK plus 1 statement is true, right? So that is what? SK plus 1 is equal to what? 10 raised to power 2 into K plus 1, then minus 1, then plus 1, okay? Is it not true? So now let us finish up this. If you finish up this, you'll be having that is 10 raised to power, that SK plus 1 is equal to 10 raised to power 2 times K is what? 2K. 2 times 1 is what? 2 times 1 is 2. So I have 2 times 1 is 2. That is plus 2, then minus 1. Then I have plus 1. Okay? Now, there is something I want to show you. I want to make 2K. If you, from here, from SK, watch. From SK, okay, let me continue. That this is equal to 10 raised to power 2K minus 1, then plus 2, then plus 1. There's something I want to show you. Now, if you separate this thing now, it's going to be 10 raised to power 2K minus 1 times 10 raised to power 2, okay, then plus 1. Now, why I did it like that is because I want to get exactly what is in SK, okay? So you now have that what? This raised to power this is 100, so this is 100 into 10 raised to power 2K minus 1, okay? Then plus 1. Now, from SK, let's make that 10 raised to power 2K minus 1 subject. You make it subject, that means it is now 11m. This one moving here minus 1. So instead of putting this, I'm going to have 100 into, to make this one subject, this one will go here. So it's going to be 11m minus 1, then plus 1. Oh God. So permit me to finish it. So I have, this time this will give you 110m. Okay, 1100. 11 times this is what? 1100m. Okay, minus 100, then plus 1. Okay, so I'm going to have that. In fact, let me have it as 11 1100m, okay, minus 100, then plus 1. So I'm going to have that this is 1100m, okay, minus 99. Now, if I bring out the 11 here, I'm going to have that this is 100m minus 9, okay? So now this is what? This is true because this is a multiple 11 with a multiple of what? This is a multiple of 11. So 11 times anything you put here. You understand? So it is true. You get? So it is true. So this is what they are asking you. This is the question they are asking. So it will lead to 11 into 100m minus 9. So if you check the option there, that is what you will have. 11 into 100, that is D, is very, very correct. So we move to question number 185, right? So I move to question number 185. I believe you are seeing the board. They've taken the light, but they'll bring it again probably. So question number 185. 185 said that the true of the expression 2 raised to power n is greater than n, comma, where n is an integer, is established, okay, is established if the assumption 2 raised to power k is greater than k, where k is an integer leads to. So I told that in objective, that is what they will be asking you, where it will lead to. So let me show you where this one will lead to as well. So solution, now normal method, the first thing is what? To assume. You assume that what? Sn statement is true. Okay, so how do you assume that? You say that what? That Sn is equal to what? Repeat the same thing. 2 raised to power n is greater than n. So the next thing to do is what? To prove. Is to prove that what? S1 statement is true. So that is what? S1 is equal to what? 2 raised to power 1. Is it greater than 1? Let's check out. 2 raised to power 1 is 2, and 2 is greater than 1. So therefore, S1 statement is true. So the next thing you do is you assume SK statement. So let's assume SK statement, which they have given us. So we assume SK, assume SK statement is true. So that is what that SK is equal to. That is what they gave us. That is 2 raised to power k is greater than k. All right. So now, what it will now lead to is in proving that SK statement is SK plus. So want to prove, it will lead to proving that. So on a normal, if this is objective, you don't need to do all this one. You just go straight to this page. That you should prove that what? SK plus 1 statement is true. So how do you do that? That is, you say that SK plus 1 is equal to 2 raised to power k plus 1 is greater than what? K plus 1. All right. Now, if you come to this place, I know that they will bring the light. Nonsense people. So if you come to this place, I want to check something. Yes, if you come to this place, I want to show you something from here, from SK. Okay, this is your answer. This is what they expect you to get. This is the answer normally. But improving it from SK, we have that SK is equal to 2 raised to power k is greater than what? Okay, sorry. But let me continue from here before I get to that place. This is what they want us to get. So this is the answer normally. But let us continue. So you have that what? 2 raised to power. Let me off my light. 2 raised to power k. Separate it times 2 raised to power 1. Okay, is greater than what? K plus 1. Now you now have that this is 2 dot 2 raised to power k is greater than what? K plus 1. Now getting to this point, you will now, if we take k to be 1, that is the first one we put, that is this first one we put, we'll be having that 2 dot 2 raised to power k is equal to what? This plus, yes, this k 1 plus 1. So which is what? 2 times 2 raised to power, 2 times 2 raised to power k is greater than what? 2. Yes. 2 times another thing raised to power this is still greater than 2. So it is proved. But what they ask you to get is just this thing. So we move to the last question. That is question number 1. Okay, second to the last question. Question number 186. So question number 186 said using principle of mathematical induction to show that n squared plus n is even for all n which is an element of a natural number leads to. I thought that in an objective, that's what they will be asking you, only what it will lead to. But me, I just want to be solving it for you in case you see that anywhere. Okay, so solution. Now, what do we do? The first method, you assume as any statement is true. That's the first thing. So let us assume that. To assume that, it means just say that what? Sn is equal to n squared plus n, right? So the next thing you do is to prove that S1 statement is true. So which is what? That S1 is equal to 1 squared plus 1, which is what? 1 plus 1. And 1 plus 1 is 2. Is 2 even? Yes. So you say that since 2 is even, 2 is even, so you will now say that therefore S1 statement is true. S1 statement is true. So the next thing you do is what? You assume SK. Assume SK statement is true. Okay, so SK statement is now that what? SK is equal to what? K squared plus what? Plus K. K squared plus K. All right. Now, since we assume that this thing is an even number, and you know that even numbers are multiples of 2. So let's say that this thing is equal to what? 2 times any number at all. Okay, where M is an element of, let me use the same natural number. So 2 times any natural number will give you an even number. 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. All of them are all even number. Okay, so the last thing you do is now to prove that SK plus 1 statement is true. So that's the last thing we are going to do. We're going to prove that SK plus 1 statement is true. So which is what? SK plus 1 is equal to, go back there and put it. You have K plus 1 all squared, then plus another K plus 1, which is what? Open the bracket, you have K squared plus 2K plus 1, then plus K plus 1. So I'm going to have that, let me bring out these two. This is what? K squared plus K, then plus what? 2K plus this, and this will give you 2. The reason I brought out this thing, because I know that this thing we assume need to be equal to 2m. So this is equal to what? 2m plus 2k plus 2. Now if you bring out 2 that they have in common, you'll be having m plus k plus 1. So this is what it will lead to. It will lead to this particular thing. So if it's an objective, this is what you just solve straight. Now you see that this is 2 times any number. Okay, 2 times any number at all will give you that. So that is that for that. Okay, so this is an even, so it is proved. So we'll move to the last question. The last question, which is 187. The last question, which is question number 187. Question number 187 says that to prove by the principle of mathematical induction that 5 raised to power 2n plus 3n minus 1 is an integer multiple of 9. Okay, is an integer multiple of 9, comma, then okay, the assumption that 5 raised to power 2k plus 3k minus 1, which is equal to 9m, leads to. Okay, so now where will it lead to? So that's what I told you, that if it's objective, they will just be asking where it will lead to. If I want to solve it straight, I'll just go straight. Okay, let me solve this one straight. But then for you, prove it for me and show me at the comment section. But let me solve this one straight. I'll just tell them that what? That SK is equal to what? Okay. SK is equal to this one given 5 raised to power 2k plus 3k minus 1, which they say is equal to 9m. So now for SK plus 1, which is equal to 5 raised to power 2 into k plus 1, okay, plus 3 into k plus 1, then minus 1. So this is equal to 5 raised to power 2k plus 2, okay, then plus 3k plus 3, then minus 1. So this is equal to 5 raised to power 2k times 5 raised to power 2 according to indices, plus 3k plus this, and this is giving me 2. Now this raised to power, this is 25. So I have 25 into 5 raised to power 2k, then plus 3k plus 2. Now, if you come to this place, make that 5 raised to power 2k subject. If you make it subject, you're going to have that 5 raised to power 2k is equal to 9m. This one moving here, you have minus 3k plus 1. So now put it inside here. I'm going to have 25 into, instead of writing this, I'll write 9m minus 3k plus 1, okay? Then plus 3k plus 2. So what do you have now? If you open the bracket, you are going to have 25 into 9m, okay? This time, this will give you 75 minus 75k. This time, this will give you plus 25, then plus 3k plus 2, okay? So you now have that this is equal to what? 25 into 9m, okay? Plus, this and this will give you minus 72k. Then this and this will give you 27 plus 27. Now, if you factorize 9, let's see what happened if you bring out 9. We want to check if it is a multiple of 9. So if you bring out 9, you bring out 9 here. So you are left with 25m. So I'm left with 25m. Okay. Now, if you bring out 9 here, you are left with 8k. So minus 8k. If you bring out 9 here, you are left with 3. So plus 3. You see? So you see that this is 9 times something. So a 9 times something means that it is a multiple of 9. So it is proved. So this is the thing they are asking you. Okay. So thank you very much for watching. Please don't forget to like, share, and subscribe. Bye-bye.